Hello everyone, welcome to my math tutorial number 19, dated 18th June 2025. My name is Mr. Lovex Israel Orengo. Welcome. Today's topic is Vectors 1, Part 2. In Part 1, I talked about the column vector in two-dimension and the representation of a vector. In this section, I'm going to talk about operation on vectors and magnitude of a vector in two dimension. Operation on vectors. It involves addition and multiplication. In this case, we usually talk about addition because subtraction would be part of addition, and multiplication it will be involving both multiplication and division. Because if I want to divide a number by 2, I can instead multiply it by 1/2. Addition of vectors. If AB equals to x1, y1 and BQ equals to x2, y2, then AB plus PQ equals to x1, y1 plus x2, y2, which is this one. Now, example 1. Given that A equals to -4, 2 and B equals to 5, 2 and C equals to -3, -5, find A plus B, A minus B, B minus A plus C. We start with A plus B. For A plus B, A is -4, 2 and B is 5, 2. We add -4 plus 5 to give us 1, 2 plus 2 to give us 4. For A minus C, A is -4, 2, C is -3, -5. We say -4 minus -3, which gives us -1, 2 minus -5, which gives us 7. For part C, B minus A plus C equals to, I've decided first to work on the bracket A plus C. That's -4 plus -3 to give us -7. Then 2 plus -5 to give us -3. Then that answer added is subtracted from B. 5 minus -7 gives us 12. 2 minus -3 gives us 5. Multiplication of vectors. Multiplying a vector by a scalar. A scalar is a constant term, that's a number. A scalar is a number. If K is a scalar and A is a vector, then K multiplies each element in vector A. For example, if A equals to xy, then Ka equals to K times xy, that's Kx, Ky. Example 2. If vector A equals to 3, 2 and vector B equals to 1, 4, find 3A plus 2B. Now 3A plus 2B means 3 times the elements of A plus 2 times the elements of B. That is 9, 6, and this is 2, 8. Then we combine the two by addition. 9 plus 2, 11, 6 plus 8, 14. Example 3. If A equals to 3, 1 and vector B equals to -2, 7, vector C equals to 6, 5, and vector D equals to 0, -5, find 3A plus C, 3B minus a third vector A plus a third vector B plus a third vector C. The scalars R and S such that RA plus SC equals to 9D. Solution. For 3 vector A plus C, we take 3 times vector A, that gives us 9, 3, plus vector C, which was 6, 5, we get 15, 8. For 5 vector B minus 3 vector A, 5 times vector B, we get -10, 35. 3 times -A, we get 9, 3. Then -10 minus 9, -19, 35 minus 3, 32. For a third vector A plus a third vector B plus a third vector C, we have a third of vector A, which is 1, a third of vector B, which is -2/3, 7/3, and a third of vector C, which is 2, 5/3. When you add 1 plus -2/3 plus 2, we get 2 and a third. A third plus 7/3 plus 5/3 gives us 4 and a third. Moving to the last part, which was saying RA plus SC equals to 9D. Now, we have R times vector A plus S times vector B, vector C equals to 9 times vector D. Now, we open the brackets. This one comes 3R, R, 6S, 5S, 0, 45. Now here we are going to form simultaneous equations. For example, the first one is 3r plus 6s equals to 0 for the x components. The y components, r plus 5s equals to negative 45. Now I would like to eliminate r. I multiply the lower equation by 3, the upper equation by 1, so that I will have 3r plus 6s equals to 0. The y becomes 3r plus 15s equals negative 135. When I subtract, this r is eliminated. 6s minus 15s gives me negative 9s. 0 minus negative 135 gives me positive 135. Dividing both sides by negative 9, s is negative 15. If s is negative 15, we now substitute s in one of the equations here. I've chosen the second equation. R plus 5 times s, which is negative 15, equals negative 45. Then r will be negative 45 plus 75. We get that r is 30. Welcome to magnitude and all sides of a vector in two dimension. Consider a diagram below. Here is a line segment AB with A at 2, 6 and B at 6, 9. Vector AB is given by 4 units along x followed by 3 units along y. Now, to get the length of this line AB, applying Pythagoras theorem, I get it is the base squared or change in x squared plus change in y squared under the square root, which gives us the 5 units. Recall that if vector AB equals to 4, 3, this implies that the magnitude of a vector given as xy is x squared plus y squared under the square root. Note that when 0 is multiplied by a vector, the such is a null or 0 vector. Such a vector has no magnitude. It has a magnitude of 0. When determining magnitude of a vector, brackets are necessary and the square sign should be outside the bracket. For example, in this case, if we are getting the magnitude of a vector and we get this number, for example, it's negative 4, if we don't put the bracket, what will happen when we square it? We say negative 4 squared without this bracket, we are going to get negative 16 plus 9, we get negative 7, which is impossible. We cannot get the square root of a negative. Therefore, what we are trying to say, when we are having that one, ensure each component is under the bracket and the sign is outside the bracket to avoid maybe incorrect answers. Now, example 4, given that p equals to 10, 5 and vector q equals to negative 14, 15, find this is the magnitude of a vector. Magnitude of a vector is shown that by the vector with the 2 parallel lines on either side. Therefore, this is a signification of parallel. This is a signification of magnitude of vector. Therefore, if I write vector A, then I put the 2 lines, it means that's the magnitude of A. Therefore, this is the magnitude of vector B plus 2 vector Q. Now, before we go to the magnitude, we first find the vector itself. P plus twice of Q. We get this one is negative 28 and this one is 30. We add it to P. We get negative 18, then 35. Now, the magnitude of this sum of the vector is negative 18 squared plus 35 squared, which gives us that under the square root, which gives us 39.36 units. We have given the answer to first figures because we were not given the level of accuracy. Thank you for watching. Welcome in advance to my 28th math tutorial.